Hello viewers. Welcome to the YouTube channel. In this video we will discuss Class 12 or 2nd PUC Physics Chapter 1, that is Electric Charges and Fields, Class 3. From basic to advanced level. So watch till end, don't forget to comment, share, subscribe the channel. In previous class, we studied Coulomb's law. One coulomb of charge in terms of current. Importance of Coulomb's law. Limitations of Coulomb's law. Permittivity of a medium. Relative permittivity or dielectric constant. Difference between charge and mass. Some other properties of electric charges. Principle of superposition of electrostatic forces. That video link is given in description, don't miss it. Today, starts with electric field. Let's start. Electric field. It is the region in which the charged particles experience electrostatic force. Electric field strength, E. Electric field strength at a point in an electric field is the force experienced by the unit positive charge placed at that point. E is equal to force by charge. That is E is equal to F by Q naught. Expression for electric field in free space due to a point charge. Vector E is equal to 1 by 4 pi epsilon naught Q by R square into R cap. Where epsilon naught is permittivity of free space. R is distance between Q and the point of consideration. Q is magnitude of the charge. R cap is unit vector in the direction of E. Note, for CET or NET. 1. C unit of electric field is Newton per coulomb. 2. Electric field is scalar quantity. 3. Uniform electric field. It is the electric field in which unit positive charge experience the same force at all point. 4. Non-uniform electric field. It is the electric field in which unit positive charge experience different forces at different points. Source charge. It is the charge which produces the electric field that the source charge can be a single charged or a group of charges or any continuous distribution of charges. Test charge. The charge that detects the effect of source charge is called test charge. Note 1. The magnitude of electric field depends only on source charge and the distance of the test charge from source charge. 2. It does not depend on the magnitude of test charge. 3. If the source charge is positive, the direction of electric field is directed radially outward from the source charge. 4. If the source charge is negative, the direction of electric field is directed radially inwards. Physical significance of electric field. Electric field E at any point around a charge is used to calculate the force F experienced by unit positive test charge Q naught at that point. That is, F is equal to E into Q naught. 1. Electric field is a vector quantity. 2. Electric field was first introduced by Faraday. 3. Electric field transport the energy. 4. It is a characteristic of system of charges and it does not depend on test charge. 5. It deals with the electromagnetic phenomena. Electric field lines or electric lines of force. It is a curved path drawn such that tangent at any point on it gives the direction of net electric field at that point. Or it is an imaginary path along which unit positive charge moves. 1. Electric field lines due to a single positive charge are directed radially outward. 2. Electric field lines due to a single negative charge are directed radially onward. 3. The electric field lines around two opposite charges are as shown in figure 4. The electric field lines around two same charges are as shown in figure. Properties of electric field lines. 1. The electric field lines, due to a pair of equal and opposite charges, start from the positive charge and ends at negative charge. 2. The electric field lines do not intersect each other. 3. The electric field lines do not form a closed loop. 4. The electric field lines are normal to the surface of charged conductor. 5. Due to isolated positive charge, the field line starts from charge ends at infinity. 6. Due to isolated negative charge, the field line starts from infinity ends at charge. Electric flux. The total number of electric field lines passing through the surface area held perpendicular to the direction of field lines is called electric flux. Or the product of component of electric field normal to the surface and area element. Delta phi is equal to summation of E delta S cos theta, where delta S is small area element of surface S, E is electric field, theta is angle between E and normal to delta S. Delta phi is electric flux through delta S. SI unit is Newton per coulomb per square meter. Electric flux is a scalar quantity. Next, electric field in terms of electric flux. Electric field is the electric flux per unit area. E is equal to electric flux by area. That is equal to phi by area. On taking area to left side, we get phi E is equal to E into area. The projection of area delta S normal to E is given by delta S cos theta. The electric flux through the area element delta S is given by delta phi is equal to E delta S cos theta. That is, delta phi is equal to vector E into delta S. Therefore, electric flux through a surface is defined as the dot product of electric field and area element. Note 1. Electric flux through small area delta S is given by delta phi is equal to E delta S cos theta. That is equal to delta phi is equal to vector E into delta S. 2. Total electric flux through entire surface is given. Delta phi is equal to summation of vector E into delta S. Or delta phi is equal to closed interval of E into delta S. 3. We have delta phi is equal to E delta S cos theta. Therefore, E is equal to delta phi by delta S cos theta. That is, electric field is the electric flux per unit normal area. 4. If theta is equal to 0 degree, then cos 0 degree is equal to 1. Therefore, delta phi is equal to summation of E delta S cos theta. Therefore, flux is maximum. 5. If theta is equal to 90 degree, then cos 0 degree is equal to 0. Therefore, delta phi is equal to 0. Therefore, flux is minimum. 6. Electric flux is scalar quantity. SI unit is Newton per square meter per coulomb. This ends electric field. In the next video, we study about electric dipole and some derivation. Don't forget to share, comment, subscribe the channel for more updates.